All right, this is question 9. We're finding volume, solid of revolution forming by roll in the region by the x-axis, y-axis, and the curve y equals sine x secant x. So we know that the volume of disks is going to be pi 0 pi over 3, and it's going to be our y squared dx in this case. So that is to say sine x plus secant x squared, which is equivalent to sine x squared plus 2 sine secant x plus secant squared x, which we're going to split into 3 separate trigonometric integrals. I will already quickly do this one. So we have 1 secant squared. Very simple. 0 pi over 3 secant squared x dx. Might as well get this one out of the way. That is just tangent. Tangent x, 0 to pi over 3. That's just going to be square root of 3 times pi. We got that part. That part is done. Now, the harder parts is these last 2 integrals. From 0 to pi over 3. Let's start with sine squared x dx. Pi out in front. That's going to be equal to our first one, which we can rewrite sine squared x as 1/2 minus 1/2 cosine 2x, which we can move 1/1/2 out. So that's going to be negative pi over 2, 0 to pi over 3. And we can split this up into 2 separate integrals, in which we have, oh wait, this would be plus. There we go. Split this up into 2 separate integrals, where now we have negative pi over 2, integral from 0 to pi over 3, cosine of 2x dx plus pi over 2 of integral from 0 to pi over 3 to 1 dx. Now, we can do some nice integration here, where we have I believe, yeah, we can just do 1/2, which is negative pi over 4, and then integral cosine is sine of 2x, 0 pi over 3. Integral of 1 is x, and that's pi over 3 minus 0, which is just pi over 2 times pi over 3, which is pi squared over 6. And we evaluate this. Thankfully, that's just 0. And it's going to give us our answer of negative square root of 3 pi over 8 plus pi squared over 6. Boom. Okay, that is our first part. So we got 2 parts now. We need now a 2 sine secant x. So we take an integral of that. Pi 0 pi over 3. That's just going to be, 2 sine of x secant. I believe it's squared. Let me check the problem. No, none of it's squared. So secant x dx, which we can write as pi 0 to pi over 3 of just 2 tangent x dx, which is just, let's write that 2 out there. Boom. So now we can write the integral as 2 pi 0 to pi over 3, and it's going to be sine of x over cosine of x dx. Now we let u equal cosine of x, du is equal to negative sine of x. So we cancel dx, cancel these out. We got a negative out front. We need new bounds of integration, so we have negative 2 pi of 1 over u du. Our new bounds of integration is just going to be cosine of 0, which is 1, cosine of pi over 3, which is 1/2. Switch our bounds of integration around. You get 1/2 to 1, positive 2 pi, 1 over u du, which is just a nice ln 2 pi, and ln of 1 minus 1/2. So let's do that first. So for 2 pi, and we have that times ln of x, or of u, of 1/2 to 1. So you have 2 pi ln of 1, it's 0, minus of 2 pi ln of 1 over half, which is just equal to pi ln of 4. Or another way of writing this could be 2 pi ln of 2. Now we have all parts of our components, and we put it all together. We have pi squared over 6. Where is it? Minus square root of 3 pi over 8 plus square root of 3 pi plus 2 pi ln of 2. This is definite? Yes, definite. So no plus c. And that's our answer to question 9.